time, it only moves in one direction, forward. And up until Einstein's theories of relativity, time was constant throughout the entire universe. However, since then, we've discovered that the pace of time can change from one observer to another. This phenomenon is known as time dilation. Time dilation occurs when objects with mass try to approach the speed of light. Their time, relative to outside observers, appears to slow down. Imagine a clock on board of a spaceship, approaching the speed of light. Humans on this spaceship looking at the clock would see it tick normally. However, humans outside of this spaceship that are standing still, looking in through the windows, would see everything moving in slow motion. And the clock that is on board would also be ticking slower. The speed of an object is not the only thing that causes time dilation. Intense gravitational fields cause objects within them to also experience a slowdown of time, as demonstrated by Einstein's theory of general relativity. This point about intense gravitational fields is important, as we will soon discuss black holes and the role they play in the movement of time. What happens if an object with mass does reach the speed of light? Well, this is an impossibility for the following reasons. The mass of an object as it approaches the speed of light would gradually approach infinity, requiring infinite amounts of energy to get it to the final speed of light. It is what we call in mathematics an asymptote, a boundary that cannot be crossed. However, there is one exception to this boundary. When a large enough star exhausts its fuel, it begins to collapse under its own weight. If the mass is right, it will form a singularity. This is a point in space of infinite density and zero volume. Now, this sounds kind of weird, and it doesn't really make much sense. This is because our equations and theories suggest that this is what a singularity is. However, in reality, this just means our equations and theories stop working when dealing with phenomena at these extremities. We really don't know what the singularity is made up of, or what it truly is. All we can be sure of is that the singularity is a point with a ridiculously large gravitational field. In fact, the gravitational field surrounding a singularity is so large that there is a region distant from the singularity and surrounding it like a sphere. This region's gravitational strength is powerful enough to capture light and stop it from escaping. This region is known as the event horizon. A singularity and an event horizon is what we call a black hole. Now just think about this. Light, the universal speed limit, and the fastest entity in the known universe, cannot escape past the event horizon of a black hole. This must mean that the gravitational strength at the event horizon is enough to cause time dilation of an object to halt entirely. I'll explain this to you with an example. Imagine we are standing on a planet, watching a spaceship approach a black hole. The closer the spaceship gets to the event horizon, the slower it will appear to be moving as its time is approaching a standstill. As it reaches the event horizon, it appears to us that the ship is frozen in time. But in reality, the ship continues to move past the event horizon and towards the center of the black hole, the singularity. I'm going to be honest with you. We don't know what happens past the event horizon, as our equations and theories no longer function properly. An object passing the event horizon, in a mathematical sense, is breaking the asymptote. However, what we can do, as futile and inaccurate as it may be, is to extrapolate these theories and equations to see what would happen past the event horizon. One extrapolation says that in the same way that time only flows in one direction in normal space, and objects with mass can move freely, this relationship is reversed past the event horizon. That is to say, an object with mass past the event horizon no longer has control of its movement in space, as it will always move towards the singularity, the center of the black hole. You see, movement in space now becomes the thing flowing in one direction, past the event horizon. However, any movement made by an object past the event horizon will no longer move it through space, but rather through time. Time becomes the entity that an object with mass can freely move through. If this is even what happens, how would it look like and feel? There is no way with our current understanding and technology to answer these questions. Whatever theories that may arise, the only truth we can obtain lies at the center of a black hole, the singularity. But to answer the question of the video, is time reversal possible? Possibly.